Section 04 in advanced geometry, still talking about algebra stuff. Still talking about algebra. Refresh our memory on a perfect square trinomial. Quite simply, it's just the result of a binomial squared. Binomial means two terms. See inside this parenthesis, aren't there two terms in there? There's an x and there's a 3. And isn't that binomial being squared? Correct? And same thing here, binomial squared, binomial squared. The result of a binomial squared is a perfect square trinomial. There's a shortcut. Some of you may have been taught to do this. First of all, you are not allowed to just square the x and square the 3 and call it done. Doesn't it really mean that you are taking x plus 3 times x plus 3? Isn't that really what you're doing? Correct? And to take a binomial times a binomial, you should remember the phrase a FOIL, right? First, outside, inside, last. Well, that's a big waste of time, in my opinion. You will really want to learn these shortcuts for Advanced Algebra 2. To square a binomial, here's the shortcut if you'd like to write them down. Let's do that now. The shortcut is the first thing you'll do is square the first guy. Then if you're in video land, you can write those down, pause the video. So here's the rules. If you have a binomial squared, let's follow it. Let's square the first term. Isn't the first term x? What would you get when you square that? You'd get x squared. Then this step 2, this middle thing right here, that's what messes people up. It's twice the product. First of all, what does product mean? Multiply. Please multiply these together. X times 3. What do you get? 3x. But we want twice that. So what do you really have? 6x. And it's positive, correct? And then finally, square the last term. 3 squared is how much? 9. And I'll just show you, if you were to FOIL that out, just for awesomeness, x plus 3 times x plus 3, you'd take first term, come on, pen, it's acting crazy. First terms times each other, x squared. Outside terms times each other, you'd get 3x. Inside terms times each other, you'd get 3x. Last terms times each other, you'd get 9. And how many 3x's were there again? How many 3x's were there? There's 2 of them. That's why you take twice the product if you combine like terms. This is a perfect square trinomial. Aren't there 3 terms in that bad boy, right? That's a trinomial. And he's a perfect square because would you agree that a perfect square is the result of something being squared? Isn't 36 a perfect square? Because it was the result of an integer being squared. Let's do that to this guy. Let's use a shortcut. Square the first term. How much do we get? 9x squared. I need twice the product. Don't think of it all at once. First, just find the product. 3x times negative 5. Negative 15x. Twice that. Negative 30x. Then square the last guy. Watch your signs. Negative 5 squared is positive 25. Cool. Try the last one. Use the 3 steps. Square the first guy, twice the product. First just find the product, then double it, then square the last guy. These are all perfect square trinomials. Why did we refresh our memory on those? Because that's the whole point of we're still trying to solve quadratic equations down here. We're going to solve them. Oh, first, I guess let's recognize to see if these are perfect square trinomials. Not bad. They want to know, are these dudes a perfect square trinomial? Well, there's 3 steps. It's basically the 3 steps that we just wrote down again. If you're supposed to square the first guy, if it's a perfect square trinomial, the first dude should be a perfect square. So let's check number 4 right away. Is the first term a perfect square? Is x squared a perfect square? Yep. Then the next thing we'd look at is if the last guy is a perfect square. Is the last guy a perfect square? Yep. Then we need to see, what I do is I actually write their square roots above them. Right? The square root of x squared is x. The square root of 36 is 6. Whatever the middle guy's sign is, he's going to come up. So that's a plus. Then I want to see, is the middle term twice the product of their square roots? That's why I wrote their square roots there. The product of those is 6x, correct? Is the middle guy twice the product of those? So this guy factors immediately. It says if it is a perfect square trinomial, factor him. Factors to what you just wrote down, quantity squared. Wouldn't that be what we'd get if we'd square this binomial? Square the first guy, twice the product, square the last guy. Cool. Because he was a perfect square trinomial. This guy, let's see if he's a perfect square trinomial. Is the first term a perfect square? Write his square root above right away, 2x. The last guy a perfect square? Yes or no? Yep, 5. Bring the middle dude's sign up. It's a minus, right? So bring it up to minus. And then is the middle term twice the product of those square roots? The product is negative 10x, twice that, negative 20x. Am I good? So he's a perfect square trinomial. He factors into 2x minus 5 quantity squared. That's a piece of cake, as opposed to frowny face factoring that guy, finding two numbers that multiply together to be 100 and add together to be negative 20. I would much rather recognize that that's a perfect square trinomial, wouldn't you? Next guy, is the first term a perfect square? Yep, square root is 4x, right? The last guy a perfect square. Square root is a 1. Bring the sign up. Is the middle term twice the product of those square roots? The product is 4x. Twice that is 8x. We are not good. So he is not a perfect square trinomial. Does that mean he can't be factored? No, it doesn't. It means it's not a perfect square trinomial. You with me on that? Maybe you could factor him. Maybe you can't. Number 7. Is he a perfect square trinomial? Is the first term a perfect square? 3x squared is not a perfect square, so this guy's a no dice. Just out of curiosity, though, what about the last term? Is the last term a perfect square? No, it's not. Why not? That's a negative 81, not a positive 81. Be very careful. Cool? So, now we will be completing the square. This is a real cool, easy trick to solve a quadratic equation when it's not factorable. First of all, let me just kind of, we'll go through one and then I'll show you which ones are factorable and not factorable. But to complete the square, there's only one time when I would use it. Completing the square is really easy or really hard, right? Sometimes it's really easy, sometimes it's really hard. Easiest time, this has to happen when the a value is 1 and the b value is an even number. That's a piece of cake to complete the square on. First guy, is a 1? Is b even? Where's b located again? Doesn't have to be in the middle. What's it? Where is it? See, like, check this out. 7 plus 2x squared plus 4x equals 0. That's a quadratic equation, correct? Which one's a? A is which one? 2. B is which one? 4. And C is 7, right? So you can't just say the middle guy, right? It's got to be, if it's in standard form, and it's in the middle guy, but A is 1, B is even, correct? Here's how I like to do it. If your teacher taught you a different way last year, please try it my way. You'll think that it's awesome when we're done. All the stuff with the x's need to be on the left side then, which they are. All the constants need to be on the right. We're going to reset this guy up with blanks. So x squared minus 6x plus blank equals 16 plus blank. You'll understand why we put a blank on both sides here in a second. But what we're trying to do is we are trying to turn this Broham right here into a perfect square trinomial. How do you turn him into a perfect square trinomial? We take half the b value, which would be how much? Negative 3, and then we square him. What's negative 3 squared turn out to be? It'll be a positive 9, correct? And if you add 9 to one side of an equal sign, don't you need to add 9 to the other side to keep that equation balanced? Correct? That's why we put a blank on each side. Why did we do this? Because now, that is a perfect square trinomial. That's why it's called complete the square. It's like, what do you need to put in the blank to complete this perfect square trinomial? But they don't call it complete the perfect square trinomial. They just call it complete the square. So now, he's going to factor, right? Really easily. Square root of this guy, how much? X. Square root of this guy, how much? 3. Do we want a positive 3 or a negative 3, though? It's whatever that middle guy's sign is. Quantity squared. Awesome. On the right side, 16 plus 9, how much? Should get 25. Y'all cool with that? Now I could tell you also, if we took a little time out, that this guy right here would have factored if we wanted to. How do I know? Because tell me about this number. What do you know about 25 or 36 or 49 or 64 or anything like that? What do you know about it? It's a perfect square. That meant that this could have factored in the first place, right? But we could also complete the square. You can solve any quadratic equation by completing the square. How do we solve this guy now? Simple. We take a blind eye to what's in the parentheses, like you can't even see that. Isn't it something squared all by itself on one side of the equal sign? How do you get rid of that square? Square root both sides. Bop, 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 bop. The square and the square root cancel each other out. And here's the real trick. Square root of 25, not just 5. What do we have? Plus or minus 5. Cool? One thing left to do, get rid of this minus 3. How do you move it to the other side? So watch what I have. Some of you may have split this up into two equations then. That's totally fine. But I got this. 3 plus or minus 5. So you got to get both of them. Aren't they both integers, right? You can add them together. What's 3 plus 5? Or 3 minus 5 is negative 2. That's what plus or minus means. You do 3 plus 5 and get 8, or 3 minus 5 and you get negative 2, and there's our solutions. When these come out as rational numbers, you could have factored it. A rational number is anything that's written as a fraction. 8 over 1, negative 2 over 1. Cool? Next guy. Why is he a piece of cake to complete the square? Sometimes it's a piece of cake, sometimes it's not. A is how much? 1, and B is even, right? So what we got to do is get him set up to complete the square. All the numbers have to go over on the other side, correct? Now let me show you something real quick before we get going. Let's say that you did this instead. Don't do this. See how I subtracted 5 from both sides? Can you find two numbers that multiply together to be 22 and add together to be 4? 1 and 22 don't, right? 2 and 11, they don't. 3 doesn't go in, 4 doesn't go in, 5 doesn't. You cannot factor this. This is not factorable. It doesn't mean that we can't solve it, though. How will we solve it? We will complete the square instead. And why would I choose that? Because A is 1 and B is an even number. So we set him up with blanks. We're going to keep all the x's on the left side, and I'm going to put a plus blank with him. And I'm going to subtract that 27 over. What's 5 minus 27? Do you have this problem, or is it different? You have a minus 27? This says minus 27, correct, on your paper? Okay, my bad. I'm going to add 27 to both sides. And what would you get over there? 32. And I need something else, plus blank. Both sides, blanks. How do you fill in a blank? Right here it tells you. Half the b value, squared. What's half the b value? 2 squared, which is 4. That goes in each blank. Nice. Now, this factors, because he's a, what's this called? Like, let's use the right terminology. What the heck is this thing called over here? Perfect square trinomial, abbreviated PST. He's a PST. He's a perfect square trinomial. It factors into the square root of this guy, x, the square root of that guy, 2. What kind of 2 do you want, though? Positive or negative? Positive. Quantity squared. And this is 36. So your problem, which was different to mine, was it factorable? Just out of curiosity, what do you think? Was it factorable? Because that's a perfect square, it was factorable. So, next move though, square root both sides, cha-cha. Square and square root cancel each other out. X plus 2 comes down. Square root of 36 is plus or minus 6. Right? Then, what's our final move here? Subtract 2. Then we got to be very, very careful. Negative 2 plus 6 is 4. Negative 2 minus 6, negative 8. One more before we go to lunch. Why is he easy to complete the square on? A is 1, B is even. So set them up with blanks. Whop-a-bow! X squared minus 12x plus blank equals 9 plus blank. All the x's were on the left already. All the constants were on the right. What number goes in the blank? You take half your b value and square him. And what do you get? 36. 36. Right? This old boy on the left factors like a piece of cake. X minus 6. Correct? Quantity squared. 9 plus 36 is 45. Woo-hoo! Was this factorable in the first place? 45 is not a perfect square, so this is the way we'd want to roll. Square root both sides. You don't have to put the radicals if you don't want to. It's up to you. Plus or minus the square root of 45. The only question is, can the square root of 45 simplify? If you go through your perfect squares, can you think of the largest perfect square that goes into 45 evenly? 36 does not go into 45 evenly. Like if you wrote out 1, 4, 9, 16, 25, 36, 49. 49 is too big, but 36 doesn't go in there evenly. 25 doesn't go in there evenly. 16 doesn't go in there evenly. Doesn't 9 go into 45 5 times? So this is really x minus 6 equals plus or minus radical, radical. 9 goes on the left because he's the perfect square. How many times does it go in there? 5 times. But this right here, square root of 9 is really how much? So you have x minus 6 equals plus or minus 3 square roots of 5. Cool with that? And now you add 6 to both sides, and you treat a radical like he's a variable. If I asked, my bad, that should be a 5. If I asked you to do this, please take 6 plus 3x right here. Sorry. 6 plus 3x. Are those like terms? Can you add that together and get 9x? You cannot add these together and get 9 square roots of 5 out of it. This is a 6. This is 3 radical 5. They are different things, right? Treat a radical like it's a variable. So as a solution set, you got 6 plus 3 square roots of 5, comma 6 minus 3 square roots of 5. You cannot add those together because they're not like terms. One of them is radical 5. The other one is not radical 5. All right, so let's move to 11. Complete the square. Why do we have to do it on this one? Because the instructions tell us to. Is it like in the order that we want it to be in to complete the square? X squared comes first. Then wouldn't we have to subtract this guy over here? So he'd be minus 5x. I'm going to put a plus blank right away. How's that minus 1 get over to the other side, though? And I'm going to put a plus blank. Yep, it will always be a plus blank because you will be squaring something, and won't it come out positive? Don't you take half the b value and square it? So it's always a plus blank. They tell us to complete the square. There is really only one rule to complete the square. That one rule is a must be 1. The a value has to be 1. The nice thing that happens is when a is 1 and b is even. Is b an even number? So this is going to be a little hairier. Personally, if it came down to I got my choice, I would not complete the square on this. But I don't get a choice because the instructions say solve by completing the square. Same concept though. I need half the b value, which, watch my side work if you will, if I want to go off to the side. Isn't that this? I accept absolutely no decimals on this. Isn't that half the b value right there? Take negative 5, put it over 2, and then let's square it. To square it, put the whole thing in parentheses and you square it. Negative 5 squared is how much? 25. And 2 squared is how much? 4. So that's 25 over 4. Don't let fractions scare you. It's just a number on top of another number. Negative 5 squared is 25. 2 squared is 4. And we put that over here also. Cool with where I'm at, with what I'm doing. This will factor very easily. It's a perfect square trinomial. Square root of this guy, boom, x. Sign comes down, it's going to be a minus. And then the square root of this guy, it's 5 halves. And if you look at that cheat sheet that I gave you, why don't you get that out real quick, cheat sheet. But what it will kind of say is, notice this right here. Every single time, isn't that half your b value right there? Negative 5 halves. Look at this guy. Was this half our b value right here? Negative 6. Isn't this half the b value? Positive 2. That's what it factors into every time. This is always half your b value right there. So you don't even really have to think about it. If you know what half your b value is, it goes right in there. Equal, oh no, got to add these together. To add fractions, you need a common denominator. This is really 1 over 1 as a fraction. But since this dude is in fourths, I need to write him in fourths. What will I need to multiply this by to turn him into fourths? Isn't that really 4 over 4? Correct? 1 is the same thing as 4 fourths. Good deal? What's 25 fourths plus 4 fourths? The denominator will stay a 4, and just add your numerators together. How much do you get? 29 fourths. Ouch! Very nasty. Is everyone cool with where that came from? Again, I accept no decimals. If you want to do this with decimals, the whole thing's wrong. Please try it with fractions. If you need help, I will help you. Right? Fractions are not that easy for everybody. Now, same concept. We'll square root both sides. But watch this awesome trick. I'm going to do this. Ba-boom! Ba-boom! Square root the numerator and the denominator separately. The reason why is because obviously this will be x minus 5 halves equals plus or minus. But the reason why I did that was because the numerator of 29, I don't like the number 29. But the denominator of 4, boy, I love the number 4. What's so great about 4, 9, 16, 25, etc.? It's a perfect square. So this denominator is a 2. The numerator, it's still the square root of 29. Right? Numerator was not a perfect square. Denominator was. Can the square root of 29 simplify? Is there a perfect square that goes into that evenly? Nope. So now it's time to add 5 halves over. 5 halves plus or minus square root of 29 halves. And even though those have a common denominator, you cannot add the numerators together because this is a whole number, this is a radical, they don't play nice. You cannot add them together. Cool? So there's our answer. 5 halves plus the square root of 29 over 2. 5 halves minus the square root of 29 over 2. That totally sucked. Why did it suck? Because the b value was odd. Completing the square is possible on every quadratic equation. It is not very nice when b is an odd number. It is actually pretty darn nice when b is an even number. So if you had a choice, I would not have completed the square on that. This one, will it be nice to complete the square, yay or nay? Yep, a is 1, b is even. Why don't you set it up with blanks and you and your partner get that one done for me? Please pause the video, give it a shot. Quick. What if I'd have done this? Let's pretend that's not there for a second. Don't cross them out. But what if I'd have taken this guy and write him like this? What if I'd have added 7 to both sides? And I got him equal to 0, correct? Question for you. Is this one factorable? Yes or no? Yes? Can you find me 2 numbers that multiply together to be 7 and add together to be a negative 8? Tell me about the 2 numbers. Both positive, both negative, or one negative? Both negative. How about negative 1 and negative 7? Don't those multiply together to be 7 and add together to be negative 8? So it'd be x minus 1 times x minus 7 equals 0. X equals 1 or 7. Same answers that I just got. It was factorable in the first place, and it was easily factorable because the a value was 1, correct? But they asked you to complete the square. Bigger eraser, please. Now, the people in the video land will be like, I never even saw you do that. Okay, I lied to you, video people. It was recording the whole time. So that's what you should have got. Next one, they want you to complete the square. Impossible to complete the square on this one. Why is it impossible to complete the square right now the way it's given to me? A value has to be how much? 1. Well, since they tell me to complete the square, I have to get the a value to be 1. Isn't there a times 4 with that in front of there? How do you get rid of that times 4? divide every term by 4, this would become 1x squared equals 10x plus 11. That was nice. Weren't all three of those numbers divisible by 4? Now, let's get them set up to complete the square. All the x stuff on the left. Go ahead and throw a plus blank in there also. And then fill in the blanks. Blanks. Billy blanks. Half the b value squared. Hey, this one should come out real nice. Dude, can't write very fast with this internet board. Hi. There's the quadratic formula right there. All you got to know is what A, B, and C are. But before you can figure those three things out, the quadratic equation that's given to you has to be in standard form. Ax squared plus bx plus c equals 0. Is this one equal 0? Get him equal to 0. Subtraction 5 from both sides. Now let's talk this out. They tell you to use the quadratic formula on this, but let's see if we try some other stuff. First of all, is this a perfect square trinomial? First term is not a perfect square. Would you want it easily factorable? Is it easily factorable? Nope. Would you want to complete the square on it by dividing every term by 2? If you divide every term by 2, this turns into a 3, which means that that's odd. That turns into a negative 5 halves, which is a fraction. I'd like to stay away from those, correct? Frowny face factor. Can you think of two numbers that multiply together to be negative 10 and add together to be 6? Negative 1 and negative 10. One of them's got to be negative, right? So 1 and 10, no dice. 2 and 5, no dice. That's it. You cannot factor this. So you have choices of either complete the square or quadratic formula. Why can't I use the square root method? Remember where you just square root both sides? I got an x to the first and an x to the second in the same thing. There are some x to the first. So let's do this. Let's use the quadratic formula. Please do this. A equals B equals C equals. Let's identify those three things. What's A? B is, and C is negative 5. Let us substitute into the quadratic formula, and every time I substitute into the quadratic formula, I say the quadratic formula out loud. I start with x equals. Then I say the opposite of b out loud, but I'm going to write down what it really is. The opposite of b, isn't that what it really is? It's negative 6, plus or minus square root of b squared. I do that mentally. I take b and square it, and you should realize you will always get a positive number in that spot, because isn't a negative number squared turn out to be positive anyway? What's b squared turn out to be? Minus 4 times a, which is 2, and I use parentheses instead of dots, times c, which is a negative 5, over 2 times a, which is 4. Cool? I said it to myself whilst writing it down. Then all I want you to do is grab your calculator and punch this in right here. That red stuff right there. Takes a little bit of work. $36 minus plus 40, did you get 76? Is everyone down with where the 76 came from? This 76 has a funny name. You should learn that quickly. It's called the discriminant. The square root of 76 is not the discriminant. Just the 76 is the discriminant. If the discriminant is a positive number, you will get 2 answers to this situation. If the discriminant is 0, you will only get 1 answer. If the discriminant is a negative number, you cannot take the square root of a negative number in the real number system. That's why you get no real solutions. Will we get a real answer, 2 answers, 1 answer, or no answers on this bad boy? 2. Let's see if the square root of 76 simplifies. 1, 4, 9, 16, 25, 36, 49, 64, 80, 64, 81. That's too big. Do any of these numbers go into 76 evenly? Work backwards. Does 64, 49, 36 go into 76 evenly? How do you know? Guessing? What would you do if you don't know? Take 76, divide by 36. Do you get a nice, neat integer? 25? No way. 16 go into 76 evenly? Take 76, divide by 16. Does it go in there? 9? 4? How many times? So this is negative 6 plus or minus 2 radicals. Didn't you say 4 went in there 19 times? Perfect square always goes on the left. I call that the Scragg number, that 19, the non-perfect number on the right. Negative 6 plus or minus, this guy becomes a what? 2 square roots of 19 all over 4. You with me on that? We're okay? Then you can check to see if it reduces, and you must look at the triangle of death numbers is what I call it. The triangle of death. These 3 numbers right here. Does anything go into all 3 of them evenly? The 6, the 2, and the 4. Doesn't 2 go into each one of those? There's our final answer. Negative 3 plus or minus the square root of 19 all over 2. Only reduces if all 3 numbers. If you have this, 8 plus or minus 5 square roots of 7 over 6, you cannot reduce the 6 and the 8 just by themselves because 5 has no one to play with. All 3 numbers must be reducible by that. Cool? And then that's where we'll leave it. I don't care about the decimal at all. Let's go on to this one. They want us to to use the quadratic formula. This is a perfect example of what the quadratic formula was invented for. Why can't you complete the square? A is not 1, right? Would you even dream of wanting to frowny face that and take 48 times negative 15? Would you even want to? No way. This one probably is factorable, but it would take you forever to factor it. Why not just use the quadratic formula instead? Is it ready to rock for A, B, and C? What does it have to be equal to? A equals 48, B equals 22, C equals negative 15. Correct? Y'all good with that? Substituting in. Again, I say it to myself, then write it down. I don't even care if you put the x equals at the beginning. Opposite of b, plus or minus, square root of b squared. That's when I grab the calculator because I don't know what 22 squared is off the top of my head. Is it 441? No, that's 484. Minus 4 times a times c all over 2 times a. Don't forget that. People leave that guy off. Is it 96, right? 48 times 2 is 96. Cool. Figure this out loud, everybody, real quick. What's that called? Starts with a D. What's that called? The discriminant. Find the discriminant. It's just the number underneath the radical. Just type exactly what you see. And what do you get? It's a positive number. 8, what? Help me out. I don't know what it is. 336. All over 96. So far, so good. Yes or no? Now, here's the thing. When this number is really large, like I say bigger than 1,000, I don't care if you simplify that radical or not. But what you should do is see if that's a perfect square. Is 3364 a perfect square? The way to check is take the square root of it. Take the square root of 3364. And if you get an integer, it's a perfect square. Is that a perfect square? Woo! You know what that means? That this was factorable in the first place. It would have been ridiculous to try to factor that, though. So plus or minus 58 all over 96. Cool? And now you will give me both answers because these are like terms. Do not try to reduce first. Simplify this. This really says negative 22. Let's do this. Take negative 22 plus 58. Punch that in your calculator for me. Negative 22 plus 58. What'd you get? 36 over 96. Or negative 22 minus 58. How much? Negative 80 over 96. Cool. Now we just got to reduce those fractions. Groovy? So let's do it. 36 over 96. You know 2 goes in there. What about, let's do multiples of 36. First of all, let's see if 36 goes into each one of those. Does 36 go into 96 evenly? Nope. I'm going to go down to 18 then. The next multiple of 36. Does 18 go into both of these numbers evenly? Does 18 go into 96? 96 divided by 18? I don't think so, right? Then I'm going to go with 9. Does 9 go into both of those? 96 divided by 9? Nope. 6? How many times does 6 go into 36? How many times does 6 go into 96? 16. Cool. So I agree that that reduced by a factor of 6. Can that still reduce, though? 6/16 to 3 over 8? Because that meant 12 went into both of them then. If 6 went in there and then 2 went in there, you take 6 times 2 and you get 12. Let's see if 12 goes into both of these. We tried 12, right? Does 12 go into 80 evenly? 80 divided by 12? Nope. Let's try 6 then. 80 divided by 6? Nope. 4? Negative 20 over, how many times did 4 go into 96? 24. That can still reduce though, right? 2 goes into each one of those, correct? So negative 10 over 12, which I can still reduce, right, to be what? So I don't care if you get it reduced on your first try. Just keep reducing it. If you want to reduce by 2 and reduce by 2 and then reduce by 2 and reduce by 2, it's all good in the neighborhood as long as you get it reduced. The only time that you'll give me these answers is when the discriminant is a perfect square. Cool. Over here, was the discriminant a perfect square? Yes or no? No. Got a handle on the quadratic formula? Feeling good at it? You want to do one more? Read the instructions. Write the best method to solve the following quadratic equations in the blank. What does it say right after that? You don't have to solve these. They're just asking you what's the best method. Here's all the methods we've learned so far to solve a quadratic. You could use the square root method. There's only one time you do it, when there's no x to the first, correct? When there's no x to the first, that's when you use the square root method. Easily factorable is when a is 1 and you can find two numbers that multiply together to be c and add together to be b. You'd have to frowning face factor when a is not 1 and you can find two numbers that multiply together to be that and add together to be this. You can complete the square. When's the best time to do that? When's the best time to do that? When a is 1 and b is even and it's not easily factorable, because why don't you just easily factorable it? 10. And then the last case, the one I would choose last, is the quadratic formula. When is the best time? When any of these methods fail or when the numbers are really, really large and none of your answers seem even reasonable to do it. Like, for example, this one. Weren't these numbers really big? There's no way I would want to try to factor that because the numbers are too big. All right? I'll just go straight to the quadratic formula. So let's try number 18 here. First of all, can I use the square root method? Why not? There's an x to the first in there. Cool. Then I noticed that the a value is 1. You got two choices when the a value is 1. Complete the square or easily factorable. Would you even dream of completing the square on this one? Even though it's possible, why wouldn't you want to complete the square? b is not even. Can you find two numbers that multiply together to be 2 and add together to be 3? So you put this. This is your method. Easy. Isn't that easily factorable? They don't want us to do it. They just want to know what would you do. This guy. Square root method, always check that first. Can you do the square root method? Nope, you got x to the first. Easily factorable, can you find two numbers that multiply together to be 5 and add together to be 12? 1 and 5? Anything else? So it's not easily factorable. But the a value is 1, right? Would you choose to complete the square, yes or no? Why? A is 1, b is even. Complete the square. CTS. Next one. Can you use the square root method? Got x to the first. Is it easily factorable? No way. Why not? A value is not 1. That means complete the squares out also. A value is not 1. Frowny face factor. Can you find two numbers that multiply together to be negative 6 and add together to be a positive 5? So this is a frowny face factor. Why not quadratic formula? Because it's factorable and the numbers are small. 21. Square root method? What do you think? No x to the first. That's square root method all the way. Add 15 to both sides. X equals plus or minus the square root of 15. Done. Right there. Next guy. Square root method? Yes or no? There's no x to the first. What's the first move you'd do, though? Divide both sides by 2. X squared equals 16. X equals plus or minus 4. Next guy. You determine with PAL. What would you do? When I see the a value of 1, and I know that there's x to the first also, I automatically look for easily factorable first. Is it easily factorable? Can you find two numbers that multiply together to be negative 3 and add together to be 8? Nope. So then I would say complete the square. A is 1, b is even. Don't call it CTS. Don't call it FFF. Don't call it SRM. Call it frowny face factor. Call it complete the square. Call it square root method, but abbreviate it like so. What about this one? I'll make up another one for you. What would you choose? Quadratic formula. The numbers are so big, why even try anything else? You know what I mean? Just go with the quadratic formula.